Alright, so hello guys, and this is my first video, and it will be on a mathematical concept called indices. Now, an index is a power to which a number is raised. For example, here we have the general ruling for an index equation where we have a base a raised to a power x is equal to a solution y. Now, what this means is that you multiply a by itself x times. So we have 2 squared, 2 times 2, 2 cubed, 2 times 2 times 2, to the fifth, 2 times 2 times 2 times 2 times 2. See, very simple. So in indices, there are few laws that you must know in order to properly understand the topic. So let's begin on those laws. First one says a to the m times a to the n equals a to the m plus n. You basically saying if you're multiplying two numbers, two index numbers, and they have the same base, you can just keep the base and add the powers. If it's dividing, same base, you're dividing, you can just subtract the powers. Let's number these. So 1, 2. Which will always is a to the 0 equal to 1. So anything to the 0 power is always 1. I'll show you the proof for that at another time. Number 4, a to the 1 power equal to a. Anything to the 1 power is always 1. It's always itself. Sorry, it's always itself. 5, a to the m power to the n power is equal to a to the mn. So if you have a number and you raise it to a power, then you raise all of that to another power, it's equal to the base to the product of both powers. A to the m to the n equal to a to the mn. 6, a to the m over n is equal to the nth root of a to the m. So these are rules of indices that you must know knowledge. Work some equations and some expressions so we know what we're talking about. First one we have here is x to the 3/5 times x to the 1/5, which by the law of multiplication would say this is equal to x to the 3/5 plus 1/5 is equal to x to the 4/5. Then you have this one, a to the 5/6 times a to the 1/3. So this should be a to the 5/6 plus 1/3, and we could change the 1/3 to a 2/6. So a to the 5/6 plus 2/6 equals a to the 7/6. Simple. This one now, for this one, you have to understand that the 1/3 power is being applied to everything within here. So we would write this as 27 to the 3rd times x to the 3rd, 27 to the 1/3 times x to the 3rd to the 1/3 times y to the 6th to the 1/3. Then you could put this using the one of the laws we saw before. We could say this is the same thing as the 3rd root 27 times x to the 1 times y times y to the two. So that's y squared. So the third root of 27 is 9. So third root of 27 is 3, sorry. So here is 3xy squared. Now, for this one, first we do the multiplying part first. So we get y to the 2 plus 4, which would give us y to the 6. When we divide that by y to the 3, that would give us y to the 3 again, because 6 minus 3 gives you 3. Now let's do one with numbers. Now, when you have an expression to simplify with numbers, but the bases are all different, you will look to see if they can be simplified down to a smaller base. So here we have 64 to the 1/3 times 216 to the 1/3 all over 8. All over 8 to the all over 8 to the 1. So this can be simplified to 64 the same as 2 to the 6. So this can be 2 to the 6 to the 1/3 times 6 to the 3rd to the 1/3 all over 2 to the 3rd. Alright, quite simple. So simplifying that further, you get 2 squared times 6 all over 8 all over 2 to the 3rd can be 2 to the 2nd all over 2 to the 3rd times 6. So 2 to the -1 times 6, 1 over 2 times 6, that's equal to 6 over 2 is equal to 3. So that's your final answer, 3. And that's where indices work.